This video is going to look at what we do when we need to draw slightly larger covalent molecules than we might be used to having drawn before at GCSE, and how to make sure that we don't lose easy marks when we're doing that. So we're probably pretty well aware with drawing something like methane. That's a pretty easy dot and cross diagram to do. Even like my GCSE students that really struggle with covalent bonding would probably be pretty happy in drawing a carbon in the centre, knowing that the carbon makes 4 bonds and that each bond is represented by a dot and cross. So methane should be super easy. We would doubt we would get that in an A-level question. Also, probably not going to get in an A-level question, would be to draw the displayed formulae of methane. And so the key to getting these more complicated ones that we've got on the rest of the screen is actually to start with the displayed formula, because we're actually much more often going to be drawing displayed formulae at A level. We're going to get a lot more confident in doing it. So for ethene, for example, I'm very happy in drawing that double bond in the middle. When I transfer that to a dot and cross diagram, notice that in the middle we've just got a cross, then a dot, then a cross, then a dot. So I'm just replacing every single bond, every line in my displayed formula with a dot and a cross, because that's what a line represents, a single covalent bond. So in the middle I've got 2 pairs of electrons. We don't need to put any other electrons in because carbon only has 4 in its outer shell and they are accounted for. What about chloroethane down the bottom left? Again, we should be pretty confident in drawing a displayed formula for that. So to turn it into a dot and cross diagram, we're going to do what we did for ethene, which is to replace every single bond with a dot and a cross. There are 3 different elements here, but we don't need to think about like having lots of different symbols for our electrons. It's just enough to show that each covalent bond is a normal covalent bond where 1 electron comes from each atom. The main thing not to forget here is that chlorine is in group 7, and so once we've done that single bond between the carbon and the chlorine, there are still 6 more electrons that need to go in the outer shell of the chlorine atom. So we would draw a displayed formula. We would replace every line, every bond in the displayed formula with a single dot and cross, and then we would check to see if there were any more electrons that needed to go on the outer shell of the atoms. Hydrogen, of course, doesn't need any more because it only has 1 electron to start with. Carbon very rarely has anything like lone pairs. It would be a charged molecule or something rather unusual. By the way, that's a clue to one of the questions. So normally carbon wouldn't have a lone pair, unless it has a charge, in which case it might. Okay, and then in the bottom right, we've got another example where we should draw it first, and we might be looking at it, and if we don't know too much about organic chemistry, we might be a little bit stuck thinking about how to draw it. If we know about carboxylic acids, we should be fairly comfortable in working out that carbon needs 4 bonds, oxygen, each oxygen needs to form 2, and hydrogen needs to form 1. So I can't have 2 C double bond O's because then I'd have nowhere for my H's to go because the carbon would make 4 bonds. And I can't have 2 COH's because then there wouldn't be enough bonds for the other oxygen. So basically it means there's a combination of a COH, a C double bond O and a CH. Once I've done that, my carbon has 4 bonds, my oxygen, each oxygen has 2 and each hydrogen has 1. Sometimes you might have to play around with the displayed formula if you really don't know the molecule yet, but the more you do organic chemistry, the more you will understand the different ways that we can put molecules together, and there aren't as many different combinations as you think. So a displayed formula of that, which is methanoic acid, would look like that. And I'm going to do dot and cross for every bond, so there are 4 electrons there because it's a double, 2 there for a single bond, another 2 for the single bond between the H's. So I'm doing all of this before I put any lone pairs in, because the number of lone pairs depends how many electrons I've already used. And for my oxygen, that's the only one that needs lone pairs. And that's a deliberate mistake where I've put an extra lone pair in there. So that top oxygen is wrong. Be careful. The bottom oxygen is fine. The top oxygen has a double bond and should not have another 6 electrons. See how easy it is? Even I made that mistake. Okay, so check, count. Count the number of electrons, make sure that they add up to the number of electrons in the outer shell of each atom. So if my oxygen is crosses, should be no more than 6 crosses around an oxygen. If my hydrogen is dots, each hydrogen should only have 1 dot, and so on. That's about it for drawing covalent dot and cross molecules. Just make sure that you draw the displayed formula first, replace the bonds with dots and crosses, and don't make my silly mistake of putting too many lone pairs in the oxygen.